This video introduces hyperbolic functions. Hyperbolic functions are a family of curves that are defined in terms of exponentials, as you will see in the notes at the top of the page. Hyperbolic sine is defined with a minus sign in the middle. Hyperbolic cos, plus sign, and hyperbolic tan, a combination of the two equations here. You will need to become familiar with these and learn them. Where do they come from? They come from a piece of work on conic sections. If we took a cone and cut through the cone at different angles, we will get different types of curves. A horizontal cut will generate a circle. A cut at a different angle will create a hyperbolic function. So we have hyperbolic curves, which in turn we can define in terms of exponentials. You will heard them pronounced as sine, cosh, and tanch, or refer to them as hyperbolic sine, cos, and tan. As you will also see, sine is an odd function and cosh an even function, in a similar way to their trig partners. Now, for hyperbolics, we are going to find values for hyperbolic functions. We are going to become familiar with their inverse and their graphs. We will then solve hyperbolic equations and finally differentiate and integrate them. So let's have a look at question 1. You are being asked to use your calculator to come up with the values. So we have sine of 6 on the graphics calculator. You are in run matrix, and it is the options button that brings up hyperbolics. So if you go for options, and then it's F6, F2 to take you to hyperbolics, and in a similar way on the class with, it's the options button. So please check that you get these values by using your calculator. And for part A, I've also written down the solution in terms of exponentials, so you can see that you get the same value. Now, question 2 then asks us to find exact values. So for part A, we are being asked to find tanch of log 5. So we sub log 5 into the definition. And then we are working with logs and exponentials. So we work with our laws of logs to turn 2 log 5 into log 25. We then have an exponential log, which means that simplifies to 25. And finally, it will simplify to 12 over 13. We are then asked in part B to solve an equation involving hyperbolic functions. So if we are solving, we can use the definition, so we can convert it to a question in terms of exponential functions. So here you can see I have replaced sine with e to the x minus e to the minus x over 2, and 2 times cosh with e to the x plus e to the minus x over 2. We are then working to simplify and generate a quadratic in e to the x. So we multiply out our brackets and multiply through by the 2 to simplify. We then collect our like terms together. So we have 3 e to the x plus e to the minus x equals 4. we need to deal with the e to the minus x. So let's have a think about what that means. We've got 3e to the x plus 1 over e to the x equals 4. I'm going to multiply the equation through by e to the x, so that will give me 3e to the 2x minus 4e to the x plus 1 equals 0. So now you can see that I have a quadratic in e to the x, so I'm in a position to factorise. So we have 3e to the x minus 1 and e to the x minus 1 equals 0. That gives us two solutions. This bracket will give me e to the x equals a third, so x will be the log of, natural log of 1/3, and from this bracket x will be 0 as e to the x equals 1. So there I have solved by working with exponentials. If you're asked to solve something that's a hyperbolic equation, you can always resort to the definitions. Sometimes the math can be a little bit long, but it will often allow you to solve an equation that you cannot solve by another method. Right, now we're going to turn over the page and look at the graphs. I've got them summarised here, but I just want to show you where they come from by looking at your textbooks. So, shine we have as this graph here, and cosh as this graph here. You go to page 121 of your textbook. The graphs are derived by working with the definition. So here we have the red curve, which is e to the x, and the blue curve, which is minus e to the x. For the definition of a hyperbolic sine, we are combining those two curves. If we combine those two curves, we obtain the black curve, which is the graph of hyperbolic sine. In a similar way, we can come up with the graph for hyperbolic cos. This time we are combining the red graph, e to the x, with the blue graph, e to the minus x, and then dividing the result through by 2 as per the definition. And that gives the black cosh curve. Okay, as you've got there. So we have shine. The domain and range are all the real values. We then have cosh, domain being all the real values, and in this case the range being greater than or equal to 1, as that's the value at which we cut the axis. Okay, I've written the definition there to remind you that you're combining e to the x and e to the minus x to obtain this curve. And then last but not least, tanh is the curve that we have here. It has two asymptotes at y equals 1 and y equals minus 1, and therefore the range is between those two values, and again the domain is all the real values. Let's have a think about why the graph is like that. It's defined in terms of exponentials here, or as shine over cosh. If we think about shine as x values tend towards infinity, as x tends towards infinity, the value of shine tends towards e to the x over 2. Likewise, as cosh tends towards infinity, as x tends towards infinity, the value of cosh becomes e to the x over 2, as this term will become tend towards 0. Therefore, I'm dividing e to the x over 2 by e to the x over 2. So as x tends towards infinity, the value of the graph tends towards 1. And we could consider the negative infinity in a similar way, and we will find that the graph tends towards the asymptote at -1. So those are the graphs, and that is your introduction to hyperbolic functions.